Once again, our topic for today is all about circles. So circle is the locus of all points in the plane having the same fixed positive distance from a fixed point. So that fixed positive distance is what we call as the radius. This is the radius of the circle, and that fixed point is what we call as the center. So again, this is the fixed positive distance. We call that the radius. And this is the fixed point. We call that as the center. So this is an illustration of the circle having the center at the origin. So let us now try to derive the standard equation of the circle. And in order for us to derive the standard equation of the circle, we need to use the distance formula. Again, we need to use the distance formula. So what is the distance formula? So the distance formula is d is equal to the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. So this is the distance formula. How do we get the value of d? And how do we get the value of x sub 2, x sub 1, y sub 2, y sub 1? So using this illustration, this is the center. And from the center going to the circumference of the circle, we have a point P. And the coordinate of the point P is x and y. So we call this as x sub 2 and we call this as y sub 2. We call this as x sub 1 because this is the first point, and we call this as y sub 1 because these are the first coordinates. So distance is also the radius. Therefore, that is the line segment CP is now equal to the square root of what? The square root of x sub 2. X sub 2 is x minus x sub 1 which is 0. So that is x minus 0 quantity squared plus y sub 2 is y minus y sub 1 which is 0 quantity squared. Again, line segment CP is the radius. Therefore, R is equal to the square root of x minus 0 is x squared plus y minus 0 is y squared. Squaring both sides, we'll be having r squared is equal to x squared plus y squared. Therefore, the standard equation of the circle is equal to x squared plus y squared is equal to r squared when the center is at the origin. So, how do we derive the equation of the circle if the center is not anymore at the origin? In this case, the center is now located at HK. So, let us try to write the equation of the circle having center at the origin. So, this is the equation of the circle. So, the equation now is that the center as HK. So, all we have to do is to change x as x minus h and to change y as y minus k. Therefore, this becomes now x minus h quantity squared plus y minus k quantity squared is equal to r squared. So this is the standard equation of the circle having the center at hk and not anymore at the origin. So this is the equation.